In this video, we're going to quickly talk about small VLMs, a smaller vision language model. We're going to talk about what's special about this and also talk about some pros and cons of this model and how it could be useful for a use case. Small VLM is available in two different parameter configurations. One is 250 million and 500 million. So here is a quick demo of how it works. So you just load the model and you just ask a prompt for a picture and you get a response. Now, as you can see, it only takes a small amount of memory, which is one of the benefits of this model. So let's look into it a bit more in depth. So what's special about this? Here's a very nice chart of how the small VLM compares to two different GPUs. One is an NVIDIA L4 GPU, one is an A100 GPU, both boasting a 4 gigabytes of memory. And as you can see, you get a lot of throughput for a very small amount of parameters, which makes sense because the smaller the model footprint, like 256 million parameter, the higher the throughput it will be because it requires less memory and less energy requirement. Not to mention, they've actually released a 2 billion version of this model, and this works competitively to the 2 billion parameter model on OCR, text visual question answering, doc or document visual question answering, chart question reasoning, science diagrams, mathematical reasoning, all-round visual reasoning, and college level reasoning, which is very, very impressive. It is going to, or it's actually showing that how you need less parameters to get equal amounts of benefits from these models. By the way, let me know if you guys want to see a fine-tuning video about this or how to build a multi-model RAG system using this small VLM. Now, this small VLM is actually built on top of SIGLIP 400 million vision encoder, which gives a lot of performance, but at a small form factor. And this model was specifically trained with various data input like OCR documents, captioning, visual question answering, and many others. What's interesting, it shows the retrieval performances to Qwen2 or Col Qwen2 and many other vision transfer models. As we can see, the small VLM is performing extremely good or quite competitively to other models, considering it has a very small number of parameters. Now, this is interesting for one specific reason, showing that if you ever want to use this model, aside from working on small edge devices, when you can fine-tune it and tune that in a specific domain, you can get some really good performance for a small amount of parameter requirement, which I think is one of the biggest selling points of this model. Now, with that said, it's also one of the downsides of this model. It's not a general model like many other models we have seen. This can be specifically tuned for specific domains and get the best performance, but it will cut short on a general enough domain where you have a lot of different things to think about. So that's something to note. They've also tried experimenting with small dockling, which is essentially a small VLM combined with a dockling, where they can create very nice looking documents to be able to present it to people, which I think has a lot of value in my opinion. I actually have to look at dockling myself. I haven't really read that much upon this, but very, very fascinating nevertheless. Here's another one. We have documents with code in a PDF and then it extracted it in a file over here. Now here they have provided the Hugging Face Transformer code on how to actually use this model. This can be done easily with the Google Colab notebook. So you guys should be able to use it with relative ease. So you may want to subscribe if you want to see more of those. All right, guys, that's a quick video on small VLM. I hope you found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. All right, guys, hope to see you in my next video. Have a nice day.